So you're driving along, and after 30 minutes you get to a place that's 50 kilometers. And it took you 30 minutes. What formula do you think we're going to be using here? What is?
Equals R times T.
Okay, so distance equals rate times time, absolutely. Now look, I know two aspects of that formula for part of my trip, don't I? I know it's a half an hour. Half an hour, I went 50 kilometers. So I know time and I know the distance. I can find my rate of speed right there. Okay, so the distance is 50 kilometers per hour. Don't know the speed, but the time is 1/2 or 0.5 hours. So what are you going to do to find the rate of speed?
Divide 0.5
Divide
into
both
50.
sides by 0.5. Divided by 0.5, anybody got that? 100. Dividing by 0.5, same as multiplying by 2.
100.
That's 50 kilometers. Sorry. That's why it's confusing. The distance is 50 kilometers, not 50 kilometers per hour. Okay, so I get 100 kilometers per hour. So that's the rate of speed. It's going to be a constant rate of speed. Assuming that you continue at the same speed, 100 kilometers per hour, how long will it take for the entire trip? How many? 4 hours. I got 400 kilometers to go. Every 100 takes an hour, right? I've got 400 kilometers to cover. Let's see what it says. Oh, we got to click here to begin all that stuff. Recall. Okay, rate can be found by what over what? Distance over time. All right. Find the rate by substituting 50 and 30 minutes, which is a half hour. 50 over 0.5 hours, right? Did I do something? Oh, 30 minutes equal 0.5 hours. Thank you. So that gives me 100 kilometers per hour. You cannot come back. Y'all realize that's what encouraged Thomas Wolfe to write his great novel, If You'd Ever Go Home Again? Working in website. I think. Good, good for us. Hey, does that mean I should have put it in as a 1/2? I guess it doesn't matter. Assuming the rate remains the same, I get 4 hours. The entire trip will take 4 hours.
Can you scroll back up?
Yes. That part?
Yes, sir.
Everybody got that okay? All right, on to the next section.
God.
Which is complex numbers. Did we talk about something called a discriminant last time? Is that I heard? I said yes, okay. So, the b squared minus 4ac, our discriminant, will let us know what kind of answers we're going to be getting. We're going to be looking at problems now that result in a negative discriminant, which means I'm going to be getting those I answers. Complex numbers with the imaginary parts. Let's look at an example like that. I think let's change this guy up just a little bit. Make it 5x squared. Let's see what happens when we try to solve this with the quadratic formula. Opposite b plus or minus b squared minus 4 times a. Square root of negative 15. And you guys know that you put that in your calculator is going to complain, right? It's going to say error because there is no real number that answers that question. The question being, what can I multiply by itself and end up with negative 15? The 15 is not the problem. The negative is the problem. I can't multiply a real number by itself and end up with negative anything. So what we're going to have to do is have a little digression here, a little move to the side, and kind of think about radical expressions that involve a negative. Right now, as far as we're concerned, as far as thinking about real numbers, there's no answer to that question. But obviously, ladies and gentlemen, we're going to have to answer that question because quadratic equations throw that possibility to us. There are going to be times in which I take the discriminant and discover it to be a negative number, which means I have a square root of a negative. So I got to deal with that set of circumstances. So what are we going to do with this negative, the square root of negative 25? Let me remind you of one of the properties of radicals. Can I multiply square root of 2 times square root of 3?
Yes.
And I'll get
Square root of 6.
square root of 6. Yeah. So I can multiply radicals with the same indexes and have no problem whatsoever. What I want to point out is that I can go in the opposite direction also. I can start with a radical expression and factor the thing. All right? So I can move in both directions, multiplying radicals with the same index, factoring radicals with the same index. That's what I'm going to be doing with this square root of negative 25. I'm going to express it as factors. Negative 1 and 25. And I'm doing that because I'm very familiar with one part of that, right? Square root of 25. That's just fine.